In this video, we are going to discuss example 6, separating a fraction. As you can see on the screen, the functions to be integrated comprise of an fractional function where the numerator function has two terms, 3x and 2, while the denominator is square root of 1 minus x squared. You can't perform this integration in one shot, but you have to separate the function into two parts, namely the part that contains the x in the numerator and the parts that contain the constant 2 in the numerator. The integration we want to seek is then obtained by performing the two integrations separately. So let's see how we do this integration. This is the first part of the integration that contains the x term in the numerator, whereas the second part is a constant 2 in the numerator. We will call this integration 1 and we will call this integration 2. The integration 1 can be obtained quite straightforwardly by using a substitution rule of u equals to 1 minus x squared. With this substitution rule, we could then convert the integrations 1 from the variable x into an integration in terms of u. With this substitution rule, we can then convert the integration 1 in terms of x into the integrations in terms of u. Once we have introduced the substitution rule, the differential of u is then minus 2x dx. So that the integrations term 1 can be cast into the form of 3 times x dx in the numerator, where x dx is just du divided by minus 2. So we write x dx as du over 2 with a minus sign, whereas the denominator is a square root of u. This will take us to minus 3 over 2 times u to the power of half with a factor of 2 plus an arbitrary constant, and that reduced to minus 3 u to the power of half plus the arbitrary constant, and we'll fill in the expression of u, which is 1 minus x squared. So that gives us the first integration of this. So now we're going to perform the integration for the second term. This integration can be performed by referring to the fact that the differentiations of arc sine is 1 over square root of 1 minus x squared. By referring to this differential rule, you can then reverse the process of differentiation into integration by multiplying both sides with a dx and then integrate. The left hand side is d dx of arc sine of x. The right hand side is 1 over square root of 1 minus x squared. This is just the arc sine of x plus n constant, whereas the right hand side is just the integration of square root of 1 minus x squared. Therefore, we come to the conclusion that the integration that we are looking for is nothing but just the arc sine. So we now have obtained the integrations for the second term, which is just 2 times arc sine of x. To summarize this video, we have discussed how the integrations in example 6 is to be performed. It has to be separated into two integrals, and these two integrals are to be integrated separately. For the first integral, we integrate it using the substitution rule of u equals to 1 minus x squared, whereas the second term is nothing but just the arc sine of x. For the first term, once you substitute u equals to 1 minus x squared, then the integration with respect to x in 1 can be converted into integration with respect to u, which is now in a much simpler form of a function u to the power of minus half. Carrying out this integration will allow us to obtain the full integration for 1. Putting everything together, we can then obtain the example 6 to be equals to 3 times 1 minus x squared raised to the power of half plus 2 times arc of sine x plus an arbitrary constant. So this is a clean statement of the result that we have just derived in this video.